As it revolves around the sun, the Earth receives life-giving energy. Without this energy, life as we know it would cease to exist. Yet the sun is only one star in a galaxy of 100 million stars, known as the Milky Way. Millions more galaxies exist beyond the Milky Way. Here, the Great Nebula, in the constellation Andromeda, where countless millions of stars are arranged in spirals. These stars are so distant that light from them, traveling at 300,000 kilometers per second, takes 2.5 million years to reach us. Our sun is simply a star which is relatively near to us. That's why it appears bigger. For us, the sun is the most vital of the heavenly bodies. We all enjoy the sun's warmth, particularly during a seaside holiday. Sunbathers realize that the sun's rays can be beneficial to their health, provided that measures are taken to prevent overexposure. The sun's heat and light come from the fusion of hydrogen atoms to make helium atoms. This dynamic condition, resulting in a great ball of white-hot matter, has been in existence for thousands of millions of years. The sun's outer surface, or photosphere, has a temperature of almost 6,000 degrees Celsius. The beauty of the sun's outer atmosphere, or corona, can be observed during an eclipse of the sun. The corona extends some 5,000 kilometers out beyond the photosphere. At its center, the sun's temperature is about 10 million degrees Celsius. The sun's energy is generated at its center. However, only a fraction of this energy reaches the Earth. But like a slow-charging battery, the Earth has stored this vital energy since before man. Some 300 million years ago, trees of the great primeval forests were drawing in the sun's energy through their leaves and building it into the substance of their timber. As each generation of forest trees was replaced over countless centuries, so the decaying remains were crushed under layers of rock, sand, and other strata. This massive pressure eventually turned the remains into fossil fuels. Marine life also draws life-giving energy from the sun. Fossil fuels are also derived from the dead marine life of long ago. One of these fuels, natural gas, is the substance of prehistoric marine plants and animals transformed by heat and pressure over millions of years. Today, the massive investments in offshore gas fields allow us to utilize this vital resource, so meeting Britain's growing demand for energy. So from the sunshine of millions of years ago, we get one of the most commonly used fuels of today, natural gas, which is essentially methane. The greatest benefit we draw from the sun is its power to grow food. Food is a form of stored sunshine. We can consume it directly without having to wait millions of years. So the food we eat and the way in which it is prepared for consumption depends upon the sun. This biscuit baking process is but one example of how natural gas, a product of the sun from long ago, is used in a modern industrial plant. We could not breathe without the sun, for there would be no greenery to provide essential life-giving oxygen in the atmosphere. Our fuel, food, the air we breathe are all benefits provided by the sun's energy. The pattern of our lives is dictated by the sun and depends on which part of the Earth's surface we live. For example, we are all familiar with the changing scene brought about by the change in seasons. 4 seasons are determined by the relative position of the Earth to the Sun. How do these seasons come about? And why is it that summertime in Britain is wintertime in Australia? Well, let's consider the seasons of the Earth's northern hemisphere. Throughout the year, the Earth moves around the Sun, while simultaneously rotating on its own axis. We can imagine this axis as a spindle passing through the poles. The Earth takes 24 hours to complete one rotation, during which Britain is part of the time in the Sun's light and part in darkness. In other words, day and night. But there is another consideration. The Earth's axis is tilted. Here the Earth is stopped in the December position, midwinter in the northern hemisphere, with the North Pole tilted away from the Sun. This tilt, which is about 23.5 degrees, means that Britain, being in the northern hemisphere, has longer nights than days. The effect of this is familiar to us all. The landscape in Britain changes because of the short winter days, which are due to the Earth's northern hemisphere being tilted away from the Sun. However, if we look at the model again, we see the tilt also results in the British Isles receiving the Sun's rays at a small angle to the Earth's surface. Therefore, Britain receives less direct heat. Because the Earth is round, the equatorial regions receive the Sun's rays at a much larger angle, and therefore get more direct heat from the Sun. So, quite apart from the Earth's tilt, the nearer we are to the equator, the hotter it is. From winter, the Earth moves on toward the spring position, resulting in a change of scene in Britain. By the end of March, the Earth is in this position, the spring equinox. The Earth's axis is at right angles to the Sun's rays. If we look at the Earth from a celestial position above the northern hemisphere, we can see that Britain spends the same time in darkness as in daylight. This is the spring equinox, the days being the same duration as the nights. The year progresses, and the Earth reaches the June position, midsummer in the northern hemisphere. Because the Earth, while spinning, behaves like a gyroscope, its axis maintains its original preferred direction. This means that because the Earth has moved to the other side of the Sun, the North Pole is tilted toward the Sun and not away from it. Britain has longer days, shorter nights, making Britain warmer. While the Earth is in this attitude, Britain faces the Sun more directly than in winter. Britain receives more direct heat from the Sun. This is because the Sun's rays are striking Britain at a larger angle in summer than in winter. A third reason why our summers are warmer is that this light has a shorter distance to travel through the Earth's atmosphere to reach Britain. Weeks and months pass, and the Earth moves on to the autumn position. Here, as in spring, the Earth's axis is at right angles to the Sun's rays. This is the autumnal equinox. Autumn brings the beautiful gold and brown colors which are so familiar to us. Nature's final burst of glory before winter sets in. The year draws to an end. The Earth is back in the December position. Winter in Britain in the northern hemisphere, and summer in Australia in the southern hemisphere. Now you can see why. So the Sun dictates our seasons as the Earth moves around it throughout the year. The sun is vital to our very existence on planet Earth. The sun, our benefactor.